Right, now that we have understood how the character data would be handled by the memory, I would like to speak about how to represent the character data, the character literals that can be assigned to a character variable within a Java program. And please remember, there are three different ways to assign a character literal to a character type of a variable. And what is the first approach, sir? The very first approach happens to be quite a straightforward approach in which directly you take the character, it must be compulsorily enclosed within single quotes, and after which you assign it to a character variable. That itself is the first approach. In which case, how would the initialization statement look like, sir? This is how the initialization statement within your Java programs would look like. Great, sir. How about the second approach? In the second approach, instead of you trying to directly assign the character symbol to a character variable, you can actually provide the Unicode value of that particular character symbol. For example, we know for the character A, its Unicode value happens to be 65. Hence, you can directly assign that Unicode value to a character variable. That itself happens to be the second approach. But we are also aware of the fact that those Unicode values happens to be integer values, and integers can be expressed in 4 different number systems. That means now it is going to be your choice. You can express that Unicode value either in decimal, octal, hexadecimal or binary according to your convenience. Just in case you decide to express that Unicode value in the decimal number system, this is how the statement would look like. Sir, what if in case I would want to express the Unicode value of the character A in the octal number system? You know, if integers have to be expressed in octal number system within a Java program, those integer literals must be prefixed with a 0. We are already aware of this. Sir, what if in case I would want to express the Unicode value of the character A in the hexadecimal number system? Then you must attach the prefix 0x. Or let us say you want to directly assign the binary equivalent of the Unicode value, in which case you must use the prefix 0b like this. And also, one important point to be kept in mind here is, whenever you are assigning the integral value directly to a character variable, you don't have to enclose those values within single quotes. It is not necessary here. Great, sir. What is the last approach, sir? In the last approach, we make use of something called as the Unicode representation of the symbol. Basically, here also you have to provide the hexadecimal value. The only difference is here the prefix, which is a escape sequence \u, must be attached at the beginning of the hexadecimal value. That means if you would like to provide the Unicode representation for the same character A, then this is how the initialization statement would look like. And like I had mentioned, this \u, technically we call it as escape sequence. And more about this maybe at a later point of time, definitely I would be discussing. And also an important point to be noted here is, compulsorily the Unicode representations must be enclosed within single quotes. And failing to do so would result in a compilation error within your programs. Anyways, the bottom line here is, it is up to the programmers to use any of these three approaches. But if you would ask me, irrespective of all of these initialization statements, whichever statement I would be preferring to use, the variable ch in the memory, which character symbol it would be holding, sir? It would be holding the character A in any of these initialization statements. Of course, it would be a 16-bit binary code. It is only for the sake of explanation. I have directly shown the symbol A there. With this, I would officially conclude my discussion on the char data type. I understand it was a lengthy discussion, but trust me, every single word that I have uttered here, every single information that I have communicated to you happens to be quite crucial for the understanding of the entire language itself. Anyways, now I would like to check your understanding with respect to the character data type. Now, before I test your understanding on the char data type part here, just in case this escape sequence is bothering to you and you are wondering as to how many such escape sequences do we have in Java, then please do understand that these are the different escape sequences or the control sequences that exist in Java. Basically, an escape sequence is nothing but a character that is preceded with a backslash, and when used within a Java program, it would signal a completely different meaning altogether to the Java compiler. What do you mean to say, sir? Maybe you will understand it better with this simple example here. This is the expected output of a Java program. I want this message to be displayed as it is onto the output screen. What is so great in this output, sir? I hope all of you are able to notice here that there is a statement that somebody is trying to report it, which Joe's friend has made. I'm sure all of you are aware of the concepts of active voice, passive voice from the English grammar. That means in the output, I want this opening and the closing double quote characters to be printed as it is. That is unique in this particular output. It is absolutely okay, sir. Seems like a simple task because we know whenever any message has to be displayed as it is onto the output screen, it should simply be enclosed within double quotes, and using the print statement, the job can be done. That means this is the solution that you're trying to suggest me here. With this print statement included within your Java program, and if you try to compile it, 100% there would be a compilation error that would be generated for the Java program. What is the problem in the print statement, sir? Please understand, the opening and the closing double quote characters that you have in between the message, which you are expecting, the compiler would treat them as just like any other characters. They are also part of the data. Unfortunately, that is not how the compiler is going to see them. Compiler would treat those opening and the closing double quotes as not part of the data. It would treat them as part of the syntax. That means these are the opening and the closing double quotes of a string literal. That is how compiler is going to consider them as. Oh, we got what the problem with this print statement is, sir. How do we resolve it? That is when you have to convey to the compiler, look compiler, at this particular time, in this particular statement, please ignore the actual meaning of these double quote characters. Let us escape from its actual meaning temporarily in this particular statement. And congratulations, to achieve that, that is when you'll have to make use of an escape sequence. Basically, you have to modify the print statement by placing a backslash just before those double quote characters, and this is how the modified print statement would look like. In this particular print statement, the moment compiler would encounter those double quote characters in between the message, now that it has been preceded with a backslash, compiler knows that I have to escape its actual meaning and simply consider these characters just like ordinary characters. Now they're part of the data. And now when executed the program, definitely there won't be any compilation errors, and congratulations, you will also be able to see the expected output onto the monitor screen. I hope with this simple example, you have got an idea about what an escape sequence really is. Anyways, it is now time for check for understanding. This is a commonly asked interview question, which is there any difference in the way as to how the character data 6 is handled in Java compared to integer data 6? Let me simplify this question for you and straightforward ask you this simple question. That is there any difference between these two initialization statements? Though in both of these statements, the data happens to be the same, which is nothing but 6. But there is a huge difference as to how Java would handle these two pieces of information in the memory. And what really makes the difference here, sir? It is the choice of the data types that we have used here to handle these two pieces of information. What do you mean to say, sir? In the first statement here, the data 6 has been stored within an integer type of a variable. That means definitely it is an integer literal. And to handle this, since we have used one of the four integer data types, we know in which case 100% it must abide by base 2 format. But whereas in the second statement here, the data 6 has been enclosed within single quotes. That means undoubtedly it is a character literal. And to handle this character literal, since we have used the character data type, in this case 100% it must follow the Unicode encoding format. Getting back to the first statement once again, the variable I has been declared using the int data type. That means definitely in the memory for this particular variable I, 4 bytes of memory would be allocated. But whereas in the second case, the variable C has been declared using the char data type, for which in the memory 16 bits or 2 bytes would be allocated like this. But we know for a fact that in both of these memory locations, neither the integer literal nor the character literal can be stored as it is, because the only type of data that is permitted in the memory is the binary data. That means now we have to convert both of these literals to their corresponding binary equivalents. And how do we proceed with it, sir? You know, in the case of integer literal, since we have to follow the base 2 format, all of you are quite familiar with the procedure. Just take the decimal number, start dividing it by 2. That means the 6, which was previously in the decimal form, this happens to be its corresponding binary equivalent. But sir, we have got only 3 binary digits here. But in the memory, I need a total of 32 bits binary code. You know what should be done to the remaining 29 bits there? It must simply be padded with zeros. In other words, if anybody would ask me, how would the integer data 6 be stored in the memory? This is how it is going to be stored. Now speaking of the character data 6 here, you know in the Unicode character set, for every single symbol, there is a corresponding Unicode value that has been assigned. That means in this case, the symbol here happens to be 6. Just like how for the symbol A, capital letter A, the corresponding Unicode value happens to be 65. Similarly, for the digits 0 to 9 also, there are the Unicode values that have been assigned in the Unicode table. Then what really is the Unicode value for the character 6? It is nothing but 54. But once again, this 54, which is the integer value here, it is currently in the decimal form. But in the memory, I don't have to repeat it once again. We have to convert it into the binary form. Only then it can be stored in the memory. And how do we convert it, sir? Similar procedure it is going to be. Just take that 54, keep dividing it by 2, and you will be able to get the corresponding binary equivalent. So the number 54, which was previously in the decimal form, its corresponding binary equivalent happens to be 110110. And once again, you might ask me the same question. Sir, here in the binary equivalent, we have got only 6 binary digits, but in the memory, I would need 16 bits. What should be done for the remaining 10 bits? Once again, it is the same padding that must be performed here. In other words, if anybody would ask me, how would the character data 6 be stored in the memory? This is how it is going to be stored. So as all of you can notice now, clearly there is a huge difference between how the integer data 6 would be interpreted in the memory compared to how the character data 6 would be interpreted in the memory. This is the last snippet on the character type of data, which is, especially during problem solving, you would be expected to remember the ASCII or the Unicode values, because both happens to be the same for the first 256 symbols for some of the commonly used characters within our programs, especially for the uppercase English alphabets as well as for the lowercase English alphabets. We know for the uppercase characters here, the value starts from 65. That means for the capital letter A, the ASCII or the Unicode value happens to be 65. And for the next character, it would be 66. Next, it would be 67 and so on. And for the last character, which is uppercase Z, the value happens to be 90. Speaking of the lowercase characters here, we know the value here starts from 97. Next, it would be 98, 99 and so on. And for the last character, which is lowercase z, the value happens to be 122. And there is an important conclusion here that I would request all of your close attention towards, which is whenever you would perform the difference between the Unicode values for any given character between the uppercase Unicode value and the lowercase Unicode value, it would always result in a constant value which happens to be 32. For example, if you would consider the symbol A, and now for that particular character, if you happen to perform the difference between the Unicode values for uppercase A and lowercase a, 100% it would be 32. And the same is applicable for all of the 26 English alphabets. Because sometimes there would be problem statements wherein you have to convert the characters either from lowercase to uppercase or vice versa. In which case, definitely this equation would come handy. Anyways, not just these characters, you would also be expected to know the ASCII or the Unicode values for these 10 digits. Because under the umbrella of the Unicode, these digits would also be treated as characters. We have just now seen one such example, the character literal 6. Great, sir. What are the Unicode values for all of these digits? Please understand, for the symbol 0, the value happens to be 48. For the next digit, it is 49, 50, and for the last digit, it happens to be 57. Also, one last character whose ASCII or the Unicode value you must know happens to be the white space character, to which the Unicode value is 32. Also, an additional piece of information here, that is, before this character, all of the previous characters are the non-printable characters. It is only starting from this character you have the sequence of printable characters starting in the ASCII and the Unicode format. Anyways, I also do understand remembering these many different Unicode values for so many different characters is quite challenging, at the same time quite confusing as well. I get that. So here's the trick. The least that you should be able to do here is at least remember the starting values for each of these categories. What do you mean to say, sir? For the uppercase characters, the starting value happens to be 65. For the lowercase characters, it is 97. For the digits, it is 48. And for the white space, it is 32. Because once you are able to remember the starting values, from there you know how the sequencing is. It is all sequential. Easily you will be able to figure out for any given symbol. Anyways, it is now time that we move on and proceed with the last primitive data type, which is the Boolean data type. Great. The Boolean data type happens to be the most simplest primitive data type, and you'll also understand the reason why. But most importantly, when do we have to make use of this data type within our Java programs? Please remember this, whenever you would wish to handle yes or no type of data, on or off, 0 or 1. Basically, whenever you would want a variable to take just one of two possible values, in that scenario, you will have to opt for the Boolean data type. Now, before I speak about the Boolean data type of Java, let us see how would this yes or no type of data be handled in C and C++ programming languages. Please remember this, in these two programming languages, the Boolean data type name has been shortened to just bool like this. And using this data type, if in case I would happen to declare a variable called as A, then I would like to know for this particular variable A, what are the different valid literals that I will be able to assign. Please understand this, in these two programming languages, I have got two options for me. Either I can assign true and false, or I can also assign an integer value. 0 indicates false, and any non-zero value, not just 1, would simply indicate true. And how about the size of this particular variable, sir? Please understand, a Boolean variable in these two programming languages would consume exactly 1 byte of memory. And how about the format, sir? Because we know true and false cannot be stored as it is in the memory. In case of Boolean, since we have got only two options here, that means true would be stored as 1 and false would be simply stored as 0. And how about the remaining bits, sir? It would simply be padded with zeros. Anyways, now it is time that we speak about the Boolean data type in Java. Please understand, in Java, the name of the data type, it is the entire Boolean word. It has not been shortened to just bool. And using this Boolean data type, if in case I happen to declare a variable like this, then I would like to know what are the valid literals that I will be able to assign to a Boolean variable in my Java program. Please remember this. In Java, the only valid literals that are allowed for a Boolean variable happens to be just true and false. We will not be able to assign any kind of an integer value within a Java program. Great, sir. But how about the size and the format of the Boolean data type in Java? Please remember this. This is one such information that has nowhere been revealed in the entire documentation. And what is the reason behind that, sir? The size and format of a Boolean variable, it is dependent on the virtual machine. That means for different operating systems, the size and the format varies. For example, maybe in Unix, if it would occupy 1 byte of memory, the same Boolean variable, maybe in Windows, it might occupy 2 bytes of memory. That is why the valid conclusion here would be the size and the format of a Boolean variable in Java happens to be simply JVM dependent, because we know we don't have a single JVM for multiple operating systems. We have multiple JVMs for different operating systems. Now, let us assess our understanding on the Boolean data type and let us identify which is the valid syntax and which is the invalid syntax. Here goes the very first syntax. Is it valid or invalid? If it was C or C++, maybe this would have been valid. But in case of Java, 100% we will not be able to assign integer values to a Boolean variable. For this reason, definitely it is going to be invalid. What about this statement? Please remember, true and false happens to be keywords in Java. They are reserved literals. They must be used as it is without enclosing them in any kind of quotes. For this reason, this also is invalid. What about this statement? As you can see, the very first letter T has been capitalized. That is the reason why this is invalid. And what about this statement? Once again, the keyword true has been enclosed within single quotes, which is not permitted. For this reason, this also is invalid. What about this statement? You can see all of the characters in the keyword true have been capitalized. For this reason, this also happens to be invalid. What about this statement? I don't even have to give any explanation. On, off, yes, no, all such values are not allowed in Java. Hence, the last statement also happens to be invalid. Then what are the valid syntaxes, sir? Like I said, there are only two valid literals for a Boolean variable in Java, and they happen to be true and false. That's it. I hope all of you have been able to understand everything with respect to the Boolean data type also. With this, officially, we have concluded our discussion on all of the 8 primitive data types.